So you see problem 2, force acceleration 1, and a canister had 2 pounds rest on the conveyor belt. If the coefficient of static frictions is mu sub s 0.2, determine the largest acceleration of the conveyor belt can have without causing the can to slip or tip, and the center of gravity at G, and the diameter that they give for the canister is 1.5 inches. So the first thing first is always you need to, just like in kinematics, we classify the motion. Classify motion. So this canister rests on the belt and it moved to the right. So basically it's not rotation because without slip or tip. So you will have that is actually a translation. And then second step, when you solve the kinetics problems, we want to find out the properties based on what is given in the problem. Properties. So the properties that you have, they give us the 2 pounds canisters, that is the weight. It always you need to find out the mass. So it will be the mass of the canister, M, it equal to weight divided by G, 2 divided by 32.2. So you get 0.6 0.0621 slug. And then they also give us the mu sub s. So you have the coefficient of static friction 0.2. So those are the properties we have. So list it out. Of course, we also have the dimensions of diameter of the canister. So you see a force acceleration. They ask you the acceleration. Whenever the question asks acceleration, then think about force acceleration method. And when force acceleration method, think about free body diagram equal to kinetic diagram. So let's do that here. We start with free body diagram equal to kinetic diagram. And for this only one body, a canister, so you will draw exactly the same canister twice. So for left side, for free body diagram, we can have the canister. Don't need to have a 3D, but let's do that in 3D in here. Equal to exactly the same canister for the kinetic diagram. So let's assume X and Y axis. So in translation, for free body diagram, so all the forces, reactions, couple acting on it. So let's draw the G, center of mass G, and the distance of this center of mass to the base. Problem gives us it 8 inches. And the diameter is 1.5 inches. So on the forces, the first is the weight of the canister, and they give us is 2 pounds. So we have 2 pounds. And then we have the normal force, and define the normal force is not always in the center. Let's define that from the edge here, ED, something we do in friction. And then we have friction between the belt and the canister. So we will have the friction, and unknowns, you can assume any direction, frictions. So that all for the free body diagram that we are very familiar with, especially when you do in frictions for this type of work. And then the second diagram is kinetic diagram. This is something new that we try to get familiar today. And in the problem 1, we already solved different type of programs. So always at the center of mass. So the height from the center of mass is 8 inches. And then for this one, you have 3 terms: MHEX, MHEY, and IG alpha. This is translation. The body is translation. You don't have alpha, so no IG alpha. G translate parallel to the conveyor, so you don't have MHEY, so it only have MHEX. MHEX. And in this case, MHEX, we can write down it equal to, because M it already know, so it will be equal to 0.0621 HEX. HEX. So that's what you have for free body diagram, kinetics diagram. So from that, we can do the 3 scalar equation. Sum of all the force in x direction equal to MHEX. So let's do that here. The equation to solve. So you have equation. So sum of all the force in x direction equal to, in static equals 0, you see MAGX. So from that, we have in x direction for the left side, it only F involved. So you will have F, because the weight equal to power vertical and vertical, so it's not involved. Equal to, instead of 0, it's MHEX in this case, as you can see, 0.0621 HEX. So that first equation. And then the second equation is sum of all the force in y direction. Let us assume it going up, equal to MHEY. MHEY. So what equation we have here? So go up. So you have N on the left side, the free body diagram, and then you have 2 pounds, the weight, so minus 2, and F perpendicular to the y direction, so it's 0, equal to MHEY. Look at the kinetic diagram, and you don't see MHEY because the G, the center of mass, is not move up and down, so it will be equal to 0. So MHEY, but MHEY equals 0, HEY equals 0, so it's 0. So from that, you can have N equal to 2 pounds. 2 pounds. Okay, and then the last equation that we use is the moment. Moment about G, always take about G, so that you can simplify the terms on the left side in the kinetic diagram. Keep that in mind. You can do other points, moment about other points, but it will be add something in the second side of the equation. It equal to IG alpha. So about G, you will have the 2 pounds go through G, so it's 0, F, G, 8 inches, so you will have that it will be F, the friction, time 8 inches. And that is counterclockwise, so it will be positive. And then the normal force, as you can see there, the momentum is this. That is the momentum. So that momentum is equal to the diameter divided by 2. So to get the radius, subtract d. So subtract d. So, and the normal force is clockwise. So it will be negative, because if you see the conveyor belts go to the right, the canister tend to, if it moving or tipping, to the left. So we will have negative and about G, keep that in mind. So you have the radius. So it will be 1.5 inches divided by 2 minus d, and equal to Ig alpha. In this case, it equal to 0 because this is translation, the body in translation, no alpha. So you have that equation. So from Fy you have n. So this equation gone. We already find n. Now we have two equations left. Fx, and you have how many unknowns? You have 1 unknown, 2 unknown. Let me make a green one. You see 1 unknown, friction, 2 unknown, and then we have d 3 unknown, right? If you can count n, then you have 4 unknowns, and you have 3 equations. So here, as you can see, it is a 4 unknowns, 3 equation. And when we learn that, if you recall what we do, we need to draw another free body diagram equal to kinetics diagram, but not the case in here. We only have one body. So with that, how can we do? Remember, if we don't have another body in friction, we have to assume something. And in this case, assume slipping and assume tipping, right? So let assume slipping first. So to have another equation, assume impending slipping. When slipping, so you will have the friction equal to mu sub Sn. So you have friction equal to mu sub Sn, and mu sub S is 0.2 in here. So you will have equal to 0.2. Normal force find out in the Fy equation. So it go to 2, so we have 0.4 pound. Okay, so let me call, and then when you have you assume something, you have to check whether your assumption is correct. So let's call that equation 1, equation 2, and this is equation 3. So from that, as you can see from equation 3, I have to check my assumption whether it's correct. So write down the equation equal to equation 3. So we have it A F minus n 0.75 minus d equals 0. And in this case, F we can replace with what we already assumed, 0.4 pound. So from that equation, and n equal to 2 pounds, we already find out. So from that, we can see only one equation, one unknown with d. So we can have d equal to negative 0.85 inches. So just to let you know, in the solution in PDF file, we define x. Instead of d. But I try to use from the center to the normal force. But here I define d so that you're familiar with what you learn in friction. So when d is minus, so it means normal force go out of the body. So as you can see, this one is less than 0. So as you can see, what does that mean? It will be tip first. So it will be tip first. So we know for sure it will be tipping first, not slipping. So now we have assume tipping. Then you will have, when it's tipping, d equals 0. So we have d equals 0. Normal force lean to the edge. So d equals 0. So that from that I can have equation 3 can be rewritten at AF minus n times 0.75 and N still 2 pounds. F now an unknown because that when it's sleeping it equal to 0.4 pounds. Now unknown, and this one is equal to 0. So you have everything is set F. So you can have from that equation F equal to 0.1875 pounds. It's positive. It means that go to the right at our assumed direction on free body diagram. And because you already know it not sleep for the first assumption, so for sure it tip. So that actually the question. And as you can see, if you see that it will be less than mu sub s n equal to 0.4 pounds. Okay, so that good, right? So that it will be not sleeping. So from that we can plug into equation 1. So I will have, you see, equation 1. So I have 0.1875 equal to 0.0621 AGX. So from that one equation, one unknown, we have AGX equal to 3.02 feet per second square. And because the canister without slipping or tipping on the conveyor belt, so they go move together, that also the acceleration eighth of the conveyor belt. So with that we solve the problem, and let's move on to the next problem.